Now we want to find the velocity of the pendulum at position x equals 4 centimeters. Once more, the amplitude is 12 centimeters. Same situation we had before. So we pull our pendulum back to this point, release it, and it swings back, attaining a velocity of between 18 and 19 centimeters per second. At this point, we want to know how fast it's going when it gets to this point. But in order to do that, we've been using energy considerations. We can calculate our potential energy at 4 centimeters. So what's the potential energy here at the 4 centimeter position? Well, the potential energy at any position x is 1/2 kx squared. So that's 1/2 k times the square of 4 centimeters, and that comes out very close to 0.001 joule. Okay, so that's 0.001 joule, approximate, but it's actually, I think, pretty close for these calculations. Okay, so now what do we know? Potential energy is 0.009 joules here, 0.001 joule here, and 0 joules here, but the energy total is 0.009 joules. The energy total here is 0.009 joules, and we used this to calculate the velocity at this point previously, because the potential energy was 0, all the total energy was kinetic, and we set 1/2 mv squared equal to this. We found the maximum velocity. So what do we know here? Well, we know that the total energy is still 0.009 joules. It doesn't vary. So what's our conclusion? Well, if the total energy is 0.009 joules here and and potential energy is 0.001 joule, that tells us that our kinetic has to be the difference, 0.008 joules. So we can write a formula. Total energy is potential plus kinetic at 4 centimeters. That tells us then that, well, first we calculate the potential energy, as we did. That tells us then that the total energy, which is 0.009 joules, is equal to our 0.001 joule potential energy plus our kinetic energy. Formally, we can solve that equation, get what we just get intuitively if we look at these numbers and understand them, that the kinetic energy is 0.008 joules, so that the velocity is what? Well, velocity, 1/2 mv squared is equal to kinetic energy. We solve that for v, and we get actually plus or minus the square root of 2 times the kinetic energy over the mass, giving us plus or minus 0.17 meters per second. Okay, now that actually, both of these velocities apply at this point. If we fall back from here to here, we've lost 0.008 joules of potential energy, so we've gained 0.008 joules of kinetic energy, and our velocity is what? Is it positive or negative? Well, it's moving in this direction, so that's a negative 0.17 meters per second. Now, this thing's going to continue through equilibrium, where it's moving a little bit faster than this, and it's going to go out to here, come to rest at a distance of 12 centimeters from equilibrium, and it's going to come back all the way to equilibrium, using up all its potential energy, so its potential energy is again 0. But now it's going to start losing, it's going to start gaining potential energy and losing kinetic energy. So it's going to gain 1/10 of a joule of potential energy between here and here, so it's going to lose 1/10 of the 0.009 joules of kinetic energy it had when it got here, and it's going to be back to 0.008 joules of kinetic energy, but now it's moving in the positive direction at 0.17 meters per second. Okay, now I don't have time to go back and correct. If I think I might have said something wrong, I think I might have said the potential energy here is 0.009 joules when it's the kinetic energy is 0.009 joules at this point. So check me on that, but make sure you're clear on just how the energy behaves. Okay, so we get this. Now intuitively, we can, and I just argued it intuitively a minute ago in terms of the picture, but at x equals 0.12 centimeters, the potential energy is 0.009 joules. Here, the potential energy is 0.001 joules, so we've lost 0.008 joules of potential energy and gained 0.008 joules of kinetic energy. Now, the kinetic energy out there at the 0.12 meter position out at the end was 0, so the kinetic energy at the 0.04 meter position has to be that 0.008 joules that was gained.